if you pass.
Hey there, Dr. Ray here, CEO of the Learning Liaisons, and in this video, you're going to be able to watch one of our recent webinar recordings where our math director, Anderson Duran, is going to focus its efforts on helping teachers, if one of you guys fall into this category, teachers who have to pass their Praxis exam for elementary education math subtest, as well as your K-6 subject area exam for our Florida teacher certification exam. So whether you are in the state of Florida or outside and you have to take the Praxis exam, this is going to be a great webinar recording for you to watch as our math director Anderson shows you how to break down those ever so difficult word problems that you'll see on your upcoming certification exams. He's going to introduce you to our proven test-taking strategy on how to analyze word problems in math, and that is destination, plan, follow. So stay tuned, watch the video, make sure you like, subscribe, and comment, and please share this YouTube channel with your friends who are in that same field of working towards their certification. So here at the Learning Liaisons, we always like to tell our teachers and college students, always remember, it's when you pass, not if you pass your certification exams. Enjoy the video and let us know what you think.
All right, and we are back. It is 11:01, and it looks like we have a few people here, quite a few people here, actually. This is awesome. So let's go ahead and dive right in, everybody. Let's go ahead and dive right in. So just want to make sure I introduce myself to make sure that everybody here feels comfortable learning from me. I am not here to waste anybody's time. So my name is Anderson, last name Duran, first name is Anderson. I'm the math director and the director of learning and development at the Learning Liaisons. And I've been here for a little over 2.5 years now, and it's just been honestly the best experience ever because everything that I've done in education has been to help other people succeed. So doing everything here, helping other teachers get their certifications and then go on to help hundreds of kids a year, it means the world to me. So I thank you guys for joining together here in this tough time. We're going to make sure this session's awesome. And, some of the other things that I've done is I've helped create courses, and I have authored courses for the GRE, FTCE, SAT, if you know any parents, Praxis, as you guys know, and AP Calculus. So again, I have some experience here in education, especially when it comes to teaching math, because the reason I became a teacher was because my professors in college, as much as I knew they were getting paid, I realized they were reading straight out of a textbook. They didn't know how to teach. They didn't put the students first. Most of them were there for research grants and things like that in that math department. And that was cool and all. But I saw that there was a little gap in terms of their ability to bring us from where we were to what they knew. And so, from that day, I kind of started dedicating my life to education and helping other people help themselves. And so you guys are in the same boat. You want to become certified teachers. You want to help yourself, and I'm just here to help that happen. So with that said, let's go ahead and keep things simple. We're going to go over this 3-step strategy, and this strategy is going to take hold in every single problem. Could be a word problem, could not be a word problem. It could be 1 + 1. We always want to apply this strategy no matter what. And so before I go ahead and talk about it, let me know in the chat box, have you heard me talk about this strategy ever before in your life? Destination, plan, follow. Yes or no? Because if not, you're in for a treat today. Nice. Quite a few people have, a few haven't. All right, so let's just go ahead then and reiterate this. That way we can continue building off of it, getting that knowledge that we need. So let's begin. The first step in solving any problem at all is destination. Destination, think about the word. It's, where am I ending up? Okay, so destination, there's 2 things you want to consider at the beginning of every single math problem, no matter what. And it's about starting simple, keeping things simple. First thing, you want to ask yourself, okay, what did I just read? Like, what's the story about? Not the math, not anything complicated. What can I comprehend here? What can I understand? What's the story about? So don't talk about math, talk about what's going on, the who, what, when, where, why. And then once you understand the context, what's going on, then, okay, what's the question? What am I supposed to end up at? What information do I want to find out? Keep it simple. Try not to use math when you don't need to, but if you do need to sometimes, hey, that's okay. but the idea is to only use things that you can easily recognize, like real everyday words or some of those simple math terms. So again, context and question, that's destination. Because once you understand where you are and where you want to end up, that's when you start bringing the math in to help you out. You start making your plan. And so in the planning phase, what you want to do here is look at your given information or what you have, where you need to end up, and you want to seriously ask yourself, okay, what math ideas or what do I know logically that will connect what I have to what I need to figure out? Or if I wanted to get the answer easily, what information would I need? So for example, in a problem that asks you, oh, what's, this playpen is this, this many feet tall, and then the question says, what's the area of the playpen? Okay, so in that question, you said, oh, I'm looking for area of the playpen. It's rectangular. Okay, if I wanted to find the area of a rectangular playpen, what do I need? Oh yeah, length and width. Oh, do I have that in the problem? Oh, I see one here, got to find the other one. So do you guys see that in terms of just the structure of solving a problem? Notice how we're not looking at the given information first, we're looking at where we're supposed to end up. And we'll see what we need to get there and see if we can find it in the problem. Because it's very complicated and very difficult to just start off by taking all of the information and hoping for the best. There's always extra information in the problem, so try not to use it. So with that said, again, context and question. Then make your math plan. Start from where you are to where you need to go. And then only when you have your plan set up, that's when you're following your plan. That's when you start calculating. So with that said, that's destination, plan, follow. Who's ready to start implementing this plan in every single problem today? Give me a yes if you're ready. Right on, right on. All right, let's go ahead and start this math party, everybody. So here's the theme for today. We're trying to tackle any math problem. So we're going to use destination, plan, follow on every single problem. Question number 1, we got 1:30 seconds. Which of the following shows 3 to the 3 2/9 decomposed? We have 1:30, starting the clock, go. And once you're ready, just type ready in the chat box. Do not, please, please, please do not type in your answer into the chat box. Just type ready. All right, good job so far, everybody. We've got about 20 seconds left, so get ready to type your answer in. We still have 20 seconds. All right, 5, 4, 3, 2. What do we got? Go. All right, so it looks like this question didn't really trick anybody. We all picked C, and that is the correct answer. So this is a topic that's going to be both on the FTCE Elementary Education Math, as well as the Praxis Elementary Math as well. So this is all about how to decompose fractions and numbers. So in this question here, we have 3 2/9, and we want to know which one of these shows it decomposed. And when we think about how to decompose a number, especially a mixed number, here's how you do it. So the number itself, you want to break it down into its unit digits. So 1 plus 1 plus 1. And with a fraction, you don't want to, the way that we would convert it and break it down into unit digits is just called the unit fractions. So 2/9 would just be 1/9 and 1/9. It's called the unit fraction in unit digits because it's just units, just ones right there all the way through. So with that said, that's why C is the answer. Is everybody cool with that one? This is probably the quickest explanation I've ever given in my life. You guys know me, I'm pretty notorious for spending like 4 or 5 minutes on one problem, but this one's pretty straightforward. And so if you see a question like this, hey, just look at it and say, thank you, burrito gods, grab it, boom, move on. All right, so we didn't really have to use destination plan follow there because it was so intuitively obvious that a lot of us were just like, oh, I know what number decompose means, boom. But you actually did it without thinking about it. So we're applying destination plan follow on problems that we truly understand. In that one, destination was, okay, I see a fraction and I see that they're asking me to decompose it. Boom, my plan, breaking down into the unit forms. Then follow that plan and do it. You just didn't think about it in the 3 steps like that. But the thing is, you already did it in that process. So question number 2, you got 1 minute. I know these problems are easy coming up, but get ready for the tougher ones coming on later. 1 minute, go. Remember to type in ready when you're ready. And we have about 10 seconds left, and I only see about 3, 4 people say that they were ready. Uh-oh. I'm going to give us an extra 20 seconds here. Let's see if we can still figure it out. This one should be good. Trady. All right, that's 20 seconds. 3, 2, 1. What do we got, everybody? Woo, we got some difference in opinions here. We got some differences in opinions. Got some A's, some C's, some D's, some B's. All right. So it looks like we're split on this one. And I love disagreement. So let's go ahead and bring us all together here. So the problem states, which of the following demonstrates the commutative property? All right. So if I'm going by destination plan follow, so I don't freak out, by all of this math here, I'm reading it. I'm just saying, okay, which of the following? So instantly, when I read a question like that says which of the following, you have to use the answer choices. You have to. And then demonstrates the commutative property. All right. So whenever I read a word like commutative property, I always think of the other properties as well. So everybody go ahead and help me out. What are all of the properties that we should know? The first one being commutative. What are the other properties? Right, Anicia, distributive, we got one there. Associative, right? And those are the 3 that we really need to know for this test. I saw the identities, Identities are just a set of facts, not a set of like mechanisms. So it's a little different. So let's go ahead and just talk about these three right here, because these are the ones that we want to know. So commutative property, think of the word communicate. Commutate, communicate, try to think of those in the same way. So I'm going to go ahead and write that here. They can communicate in different ways. Associative, think about it like this. Well, you can associate in different ways. And then distributive, well, think of the word distribute. Very straightforward with these three terms. Now, when we look at A, B, C, and D, let's go ahead and pick apart which properties these are. So A, we have in a parentheses, -1 plus 8. And then we're adding a -10 beyond it. Now on the right side of the equal sign, what we see, we have the -1 still in the same place, the 8 still in the same place being second, and the -10 still being there in the third. The only difference is that the parentheses grouped the -1 and 8 together and then moved to group the 8 and -10. So essentially, the parentheses just moved from the left here to right here. So when that happens, what are we doing here? Are we associating two numbers in a different way? Are two numbers communicating in different ways? Are they distributing something to the numbers? What are we seeing here? And so to get this down and know this definition like the back of our hands, what's really going on here is that we are associating a parentheses with different numbers. We're associating the parentheses with different numbers. So this is the associative property. Does everybody agree with what I just said? All right, awesome. So yeah, that's what's going on. If we associate two different numbers and it doesn't change the outcome of the equation or the expression, yep, that's associative, because you can associate the parentheses and still keep the same answer. Now, B. Again, I'm just going to analyze it fairly quickly. I'm going a little slow here to break it all down, but on test day, if you want to be quick here, we have 2 minus 3 plus 4. What changes? 4 minus 3 plus 2. So it looks like the 2 and the 4 were swapped. The -3 or the -3 stays in the middle. So with that said, it looks like they're saying, hey, it doesn't matter what the order is. We can have 2, then -3, then +4, or we can communicate it a different way and say 4, then -3, then +2. They're both going to be the same result. So notice that we can communicate the numbers in different ways and still get the same result. So this would be which property, everybody? And I want you to type it out, because the more you talk about it, the more you type about it. I know it's a little inconvenient to type it all out, but I want you guys to do it, because again, the more you talk about it, the faster you get better. Seriously, something as simple as repeating it in the definition or typing it out really does help. Yep, it's commutative. Exactly. And that's why B would be the correct answer here. If we look at C, what's happening here? It looks like we go from 2 multiplied by 4 minus 5, and we ended up with 8 minus 10. What ended up happening here was that the 2 was distributed through the 4 and -5, which gives us the 8 minus 10, and that's the distributive property. So what the distributive property says is that if you have a number being multiplied to a group or parentheses, then you can distribute or multiply that coefficient onto everything inside and still preserve that true statement, or still keep the equation, true. The last one here, we have 2 plus 2 plus 8 turns into 4 plus 8. This is just simplifying. All right. This is just simplifying. This is just grabbing your like terms and simplifying your like terms, or adding your like terms, or subtracting your like terms, whichever way you see it. You're just simplifying like terms. That's all it is. So with that said, how are we feeling about example number 2? You know, where were we before, and do we feel better now, or do we still have kind of the same level of understanding as we did before? Sweet. Because I know a lot of us have seen these terms before. You know, it's obvious. Like we've all been in grade school. But the thing is, you know, the question is not whether we recognize it. It's more so about, hey, can you talk about this? Can you explain this well enough to be able to really see any type of problem about it? So let's go ahead and recap again, destination plan follow. I started off by saying, hey, which of the following? Gotta use my answer choices. That helps me not freak out, because if I look at, you know, things like this, I'm like, oh, what the heck? What's going on? But when I read which of the following, oh, I just have to analyze something about these problems or these equations. And that helps me stay a lot calmer than I would have if I would have just said, oh God, all of these equations, I'm done. And then just read demonstrates commutative property. So I went through it, found which one it was, and I'm done. So there it is again, destination plan follow. Question number 3, diving right in, 2 minutes here. This is not expression, sorry about that. This is percent. But here we go, 2 minutes. I'm gonna go ahead and start the timer right now. 3, 2, 1, and go. And remember, everybody, once you have your answer, once you're ready, just type it ready in the chat box. That way we can make sure no one sees any answers. We've got about 40 seconds here, just about 40 seconds. We have 10 seconds here. 5, 4, 3, 2, and 1. What do we got? All right, got some D's, got some C's. All right, so no A's or B's, strictly D's and C's. Okay. Okay. We got an A now, okay. All right, looks like a lot of folks here. All right, so the majority of us agree that it's either C or D. All right, so let's go ahead and go over it. But first and foremost, as always, destination, plan, follow. All right, so let's go ahead and run through it nice and smoothly. So remember, when you read the problem the first time, you don't want to focus on the math. You just want to focus on the story, what you can recognize. So a group of students are working on a project. All right, that's pretty self-explanatory. Cool. So students working on a project, if they can complete this much of the project in this much time, how long will it take them to complete the project? So the story, destination, again, only focus on what you can immediately recognize and talk about. We're talking about a couple of kids that are working on a project. They've completed some piece of it after a certain amount of time. And we just want to know how long it's going to take them to complete the whole thing. So with that said, with that first initial step there with destination, did everybody understand that, again, all we're just talking about, group of kids working on a project, they've completed some of it so far, we just want to know how much time it's going to take them. Sweet. Perfect. That's where we want to start here. Again, we just want to figure out how long it's going to take them to complete that project. So when I go into the planning step or the planning phase here, the first thing I want to do is write out my answer. Not the exact number, obviously, but the units or whatever we're discussing. So if they're saying how long will it take to complete the project, I'll say blank what? What are the units that we're using for how long it's going to take? What are my units here? So if I'm writing my answer, blank what? Because here it would be 42 blank, 48 blank, 54 blank, 60 blank. Yep, exactly. Blank hours. Exactly. Blank hours. And if we really wanted to fill in that blank, here's my recommendation. When you write variables, from now moving forward, here's what I recommend you do. Only use letters that pertain to what you're solving for. Don't always use X. I know everybody has a really bad habit of always using X. The thing is, sure, you're perfectly allowed to do that. But the thing is, you want to build a further connection with the problem that really shows that you understand and you're interested in what you're doing. Obviously, you know, math is tough, but the more that you associate with it intentionally, the easier it does get because it is a language. So just like learning any other language, the more you try it intentionally, the better you get, then the faster you get at it. So that has something to do with it. So we're looking for H hours. Now in our plan, let's go ahead and start writing some of the given information. So let me erase what I wrote here. And now let's go ahead, boom, 30% of the project in 18 hours. That's a pretty important piece of information. Also, how long in hours, which I already have here, so that's good. But that's really what I have. All I have is 30% complete. In 18 hours. All right, so for those of us who believe that we got it right, go ahead, type out the equation that you probably maybe set up to solve this. Or if you didn't set up an equation, you know, what calculation did you do to get it done? So I'll give us a second to type that out. So how did we go about it in our way? $18 divided by 30, 0.3 times 18, percent of is 100, cross multiply and divide. Okay. I like this now. I like this. So a lot of us use a couple of different ways, but what I did recognize is that a couple of us noticed that we can make a proportion. And what I mean by that is a proportion is an equation where the same things are being compared in the same ways. So again, a proportion where the same things are being compared in the same ways. So if we have 30% complete in 18 hours, we're going to have 100% complete in how many hours, guys? What's that? What should I fill in the blank with? That's right, Sedaria. Thank you. With H hours. I'm talking about like with what we know so far, not the answer, guys. So 30% complete in 18 hours. No worries, you're good. 30% complete in 18 hours, 100% complete in H hours. So there we are. And what we want to do here is set up a proportion. So again, we want to compare the same items in the same way. So we can set it up as 30% out of 100% equals 18 hours out of H hours. The reason this is okay is because 30 represents 30% of the work, and 18 represents 30% of the work just in the form of hours. 100 is the percent of the total work. This is the hours of total work. So notice on the left side, we're just comparing percents. On the right side, we're comparing hours, but they're being compared in the same way, and that's good. That's all we need. Others may have set it up in the following way, and this is still correct as well. Some of us may have set it up as 30 over 18 equals 100 over H. Another way could have been, we could have done H over 100 equals, and then we could have said 18 over 30. That's another way to do it. So those are three of the more common ways. I think there's one more that we can do, but I'm going to leave it right there. But the thing is, these are all correct. All you have to do is compare the same items in the same way. So I'm going to write this down for everybody or anybody who has a struggle with proportions. So compare the same items in the same way. And you're good to go. So again, percent total, hours total, all good. Percent part, hours part. Then we have percent total, hours total. So again, just compare the same items in the same way and you're good. So with that said, who's ready to just knock this out right now? What do we get when we get the 30 and H together when we cross multiply? But what do we get when we have 100 multiplied by 18? What do we get, everybody? Help me out. Correct, 1800. Yep. And so from here, the only thing we have to do now is just divide both sides by 30, and we're set. Because what's going to happen on my left side, 30 is canceled out, leaving us with H equals 60. And so remember to answer it in the context of the question. 60 what, everybody? Make the connection with the problem. 60 what? Boom. First goes to Wadi. Perfect. So boom, 60 hours. And 60 hours is, again, how long it'll take to complete the project. Again, it's super important that once we're done, that, when we're practicing especially, that we're not just, oh, there's the number, plug it in, that's my choice, and move on. We don't want to do that. What we really want to do is, again, solve the problem, get the number, and then relay the number back to yourself. Okay, so I got 60. I was trying to find the number of hours it'll take to complete this total project. So 60 represents 60 hours to complete it all, with all the group of students working together. Boom. So you've tied it all back together along with the story, and you've made a more meaningful connection with the problem. And it's more than just circling the right answer and moving on, because you reflected on it, you see what you did right, you see how you can apply that to the next problem. And with more problems under your belt, you'll start doing it automatically, as opposed to having to really give that effort every single time. So with that said, who's liking destination, plan, follow so far? Because notice we're not calculating at all until the very end. So who likes this strategy so far? Is it helping anybody? And if so, how is it helping you? Now, what were you doing before that kind of made you struggle? Yeah, I want some real answers here. I just realized we're live on Facebook too, so I'll be relaying some of these answers to folks, and I'm not gonna say any names though, so you're good. But what were we doing before learning destination, plan, follow, and how does this strategy help you now? That's my question. starting to take root. With a few more problems, you're going to grasp it. I love that. Helpful with organizing the problem clearly and not making common mistakes. That's exactly why we do it. Determining when to use proportions or other math concepts. Exactly. It's a good visual. It helps you slow down a bit and understand what you're doing. I was just jumping to the math and going, and my answer didn't always make sense. Girl, that is exactly what I'm talking about. Because the thing is, again, how many of us have started a word problem and the first thing we did was just start grabbing our calculator, mash some buttons together, and really just hope for the best? You know, praying to the burrito gods or singing Hail Mary or something like that. And then if you see a number that shows up on your calculator, great. But the thing is, there's no methodology behind that. There's no confirmation behind that. There's no confidence behind that. And so that's what I'm teaching, how to be confident. So some more. It's a new strategy to me and is making the process easier to understand by piecemealing. I love it. I personally was just ready and trying my best to answer questions. Now I'm really trying to not read too much into it. Exactly, keeping it simple, starting simple. I can see the whole picture now. Before I used to freak out when, and then it cuts off, when I see all the numbers, right? Setting up the problem is my issue. Therefore, helpful in knowing how to set up the problem. There we go. On the fence, to be honest, when I looked at the FTCE bootcamp, the instructor told me to look at the answers first and remove outliers. Removing outliers is definitely a great strategy to use. With the math, here's the thing. When it comes to the reading, writing, essay, you can learn the strategies, the simple strategies behind it, and apply those only and still pass. But when it comes to the math, the majority of this test is going to bank on your ability to understand the math itself. So that strategy still works, but you want to apply that strategy when this first strategy does not work. So when you don't know the math or when you don't know how to break the problem down. It helps me really understand what the problem is asking. I love it. It helps you think first before the strategy. Just look for the numbers. It's helping me map out the problem all the way to start to finish. I love it. Mental math and elimination, but no formula for checks and balances. Trying to analyze all parts of the questions. This is great. So we're all growing in some way, shape, or form here. So let's go ahead and dive right in. Question number 4. A minute, 30 seconds. This one's on geometry. Starting the timer in 3, 2, 1, go. All right, halfway done here. We got 45 seconds left. 45 left. Three, 2, 1. Answer. What do we got? I just realized I was muted. I was like, no one's posting their answers. Everybody's pretty nervous about this one. All right, got some B's, got some C's, got some A's, got some no clues. That's all right. So I love this question. Looks like I stumped a couple of us here. And again, this problem is going to be on both the elementary math and Praxis elementary math. both of these problems could be on there. God, take the wheel. Indira, well, hey. Not yet. Let's go ahead and let's reserve that. And don't know yet. Scalene deals with different lengths, I believe. Ooh, there we go. There we go, Fred. So let's go ahead and talk about this. So two vertices of a scalene triangle are shown below. All right. So again, only talk about what you can easily recognize. If it's something that is like a definitive vocabulary word that maybe you got to think about for a second, just go ahead and highlight it or underline it. And if we're taking a computer-based screen, then just go over the word. All right. Just take note of it and be like, don't know that word, but whatever. Don't get hung up on the simple or the complicated things. Not yet, at least. So again, two vertices of a scalene triangle are shown below. All right, I'm going to skip that because that's a lot of math stuff. But the question says, which of the following, and remember what I said, which of the following means I need to analyze these answer choices. Boom. So which of the following ordered pairs, yes, these are ordered pairs, of the third vertex, okay, third vertex, I'm going to highlight that, would result in a scalene triangle. Okay, so I'm not going to try to think too far into this. I'm just going to try to break that question down because this is almost a pure math question. But what I did understand was which of the following, so analyze these choices or maybe plug them in. Ordered pairs, again, those are ordered pairs, be the third vertex resulting in a scalene triangle. Okay, so we want the third vertex to form scalene triangle. We're going to break that down in one moment. So we need an X and a Y. We need a coordinate. Now, let's go ahead and break that down. Third vertex. Well, third vertex in what? Well, we're talking about a triangle. And how many vertices or how many points do triangles have, everybody? Right, we're going to start with the standard information that we can work off of. So we know that triangles have 3 vertices, and we're here in this problem, it states that we're looking for that third vertex. So with that said, well, my first question is, do they give us the first 2 at all? Like, do they give us the first 2 vertices? Right, they absolutely do. When we check out the first part of the problem, it states 2 vertices of the scalene triangle are shown below. They're shown here and shown here. And there's a word that I've seen twice now, scalene. So we need third vertex to form a scalene triangle. So goal, scalene triangle. What does it mean for a triangle to be scalene, everybody? So let's be specific, not equal in what way? Let's go ahead and state so that everybody can rally behind that thought. Scalene triangle. What is a scalene triangle? Twos, not quite. Wait to see who can get it spot on. Boom, Fred, you got it. Exactly. Yep, we both got it. So again, for a scalene triangle, none of the sides are equal in length. I'll say equal, but the correct term is congruent. All right. So our goal is to find that, which of these will give us no sides being congruent for a triangle. And now, what do we have so far? What's my given information? Well, I'm told that the 2 vertices are here and here. So let's go ahead and name these coordinates. What's this first one down here? What's the name of this first one? How do I name it? Well, no, we just want to name the coordinate. So some of us are saying 0, 4, others are saying 4, 0. So let me go ahead and clear up that confusion for one moment. When we name vertices or coordinates, we are going with the x coordinate first and then the y coordinate. It goes in alphabetical order, x, then y. And so the x is here, and that's 4. The y, or how far up and down it is 0, because going up would be positive, down would be negative, but on the line is 0. So this is 4, 0. No worries. Hey, I'm glad that I could just clear up that confusion. And then here, same deal, where the x naming first. Again, it's positive over here, negative over there. So it's 0 right now. And the height is all we're looking at, which is 4. So we have 0, 4, and 4, 0. Let me separate these a little bit. That way it's not too confusing. So with that said, now what we're going to look at are the third vertices that are our options here. Because the thing is, we're given the coordinates, and we want to know which one of these can we plug in to make it scalene. So let's go ahead and start off with 0, 0. If I were to go ahead and plug in 0, 0 right here and made a triangle, what kind of a triangle would this be, everybody? Would it be scalene? Okay, so we see that it's a right triangle, but is that really important in this problem, though? Because a right triangle can be scalene. So let's go ahead and only use the information that we really need to think about. And the 3 types of triangles that we can have, remember, they are scalene, they are isosceles, and the last one is equilateral. These are the 3 types of triangles that we can have. So in this case, we would definitely not have a scalene triangle, simply because this would be a length of 4, and that would be a length of 4. So everybody, before I continue, give me a yes if you understand that A is not the answer, because the coordinate 0, 0 would create an isosceles triangle. Perfect. So what I'm going to do now is I'm going to go ahead and go back. And again, this is isosceles. So that can't work. Now I'll move up to use blue here for this one, -4, 0. So going back, let's erase what we've got. Bye-bye everything. And I'll go to -4, 0. Again, the x is first, then the y. So -4, 0 is right there. Now I can go ahead and draw this out. What kind of a triangle would this one be? Or is there anything that we know about this that even if we don't know what the exact lengths are? So not equilateral, this one would actually, at the very least, be isosceles. Here's why. We're going from this coordinate right here. We're going from right there, and it's going the same distance. It's going down 4 over 4 to get over here, and it's going down 4 and over 4 to get over there. So it's perfectly reasonable for us to say that these 2 sides are equal or congruent. So this one is isosceles no matter what. It is not going to be equilateral because this is actually way longer. That would actually be, I believe that would be a right isosceles, I believe. Yeah, it is actually a right isosceles because this is 45 degrees and that's 45 degrees. So this is a right isosceles triangle. So boom. So with that said, this is again, isosceles wouldn't work. Next, C. 4, 8. So let's take everything down again and write in 4, 8. So here's 4, 6, 7, 8. So I can connect the dots right here. Boom. So there's my dot that I'm going to connect. All right. So if I go ahead and work this out, what do I see? Oh, whoops, I made a huge mistake. Oh man. Need to go up from here. Boom. So when we take a look here, here's what we got. Straight line there, and then up. And this is the same situation. What we're gonna have here is, well, this side and this side are the same. Because again, for this point to go to this point, what we see is going over 4 and up 4 to get to 8. This one is going over 4 and down 4. So again, same distances, so the sides are equal. That would be isosceles yet again. So far, are we all good in understanding why all 3 of the first options are isosceles? Yes or no? All right, perfect. So then by default, we can say that D is the answer. So by default, we can say, yeah, D24 is the answer, but I don't want to cheap shot you guys. I want you to see everything that is being, that's necessary to see. So 24 was the coordinate, right? 24, perfect. So what I'm going to do is I'm going to graph 24 right here. Sorry, right there. And when we think about it, all right, cool. Here's what we're going to see. And there it is. So that would definitely be a scalene triangle. So with that said, scalene again, no equal sides. So taking a look here, this would be a distance of 2 right here. You can actually use the Pythagorean theorem to find this one out, but we know for a fact that this angle is the biggest one. So this is the biggest side. And then this angle, or this side here, has the smaller angle. So it would be, slightly bigger than this side, but not bigger than this one. So we know that there's a hierarchy here. We're cool. Equilateral is when all the sides are the same. All 3 sides are the same. That would make it equilateral. So if we had a triangle, let's say, for all 3 sides to be the same, again, we would just need to see something along these lines. Something like this. Equilateral just means all 3 sides are the same. That's all it means. And so we would need to see all 3 sides being the same or be able to measure that to do it. But in this problem, we were only looking for what would make it scalene. And so we just went through all 4 choices, found that the last one is the one that works, and we're good to go. So with that said, who feels better about this one? Even if you got it right with a guess, do you see why D is the right answer now? Because again, I don't care about which answer is right. I care about why it's right. So who's benefiting from this right now? Who understands what's going on? Sounds good. Remember, as teachers, we make sense, not dollars. So sip some tea. All right, so let's go ahead then, reflect, or not reflect, but dive right into the next one here. That's right, we got some coffee. All right, so number 5 coming up. We're gonna have 2 minutes to get this one done again. So let me go ahead and set my timer. All right, we're getting started in 5, 4, 3, 2, 1. Let's get it done. 2 minutes. In 3, 2, 1. What are their answers? All right, that's not good. C, D, A, C, B, D, A. Okay, looks like we're all disagreeing right now. Looks like it may have taken us a little more than 2 minutes to get something like this done. But let's see what the rest of the answers are. More D's. You got a C in there. All right, so let's go ahead and review it then. Let's review it. So let's review it. Let's review. Destination plan follow, even though it's an equation. Again, destination plan follow always applies. So begin by, again, not addressing the complicated stuff. So if I'm reading this problem, I am not going to spend or waste my time going 3x minus 2x plus 2x plus x minus, no need to read all that. Just go straight to the question. Which of the following? Okay, in my head, if I have an equation up here and I got numbers here, we're looking at what the answer is to this. But let's see what the question says. Which of the following is the value of x in the equation above? All right, we've seen problems like this before, so boom, check it off. Solve the equation, get x. Sweet. So what I'm going to do first is I'm going to see, look, in solving equations, there's usually something everybody does. Get the x's on one side, get the numbers on the other, and then divide. That's usually the goal. Now, they're going to present these problems to you guys in different ways. Ways that would make sense if you looked at some nice simplification steps before you began. So for example, some of us may be inclined to start the problem like this. Oh, let's start off by doing 3x minus 2x to get x. Then I'm going to add 2x, and that's going to be 3x. Then I'm going to add x here, and I'm going to make that 4x. Now, notice how we're going line by line, and we're kind of spending some time doing that. Here's something that I would really suggest that you do moving forward. Instead of going, straight left and right, simplifying, try this out instead. I noticed that we have a negative 2x and a positive 2x. So if those were to combine, what would happen, everybody? They would what? Absolutely. They would zero out, they would cancel, they go gone, they go bye-bye, exactly. So 2x, negative 2x cancel each other out. Next, I'm taking a look again. And this is a little more technical now. So you know how if you have a negative and positive on the same side, they cancel out. Here's something that's also true. If you have the same sign on the same term, on each side of the equation, those also cancel out. Here's what I'm referring to. I'm referring to the x and the x here. You want to know why? Here's why. If I have the x here and the x here, they're going to cancel because I can subtract x from both sides and cancel on both sides. That's why if you have the same term with the same sign on each side, you don't have to do the work. You can simply cancel them out automatically. Because again, the premise, the idea is that you can subtract on both sides, and since they're the same term, they both are gone. So does that make sense, everybody? I want to make sure that, I'm teaching you how to conserve your time on this test. Sweet. Right on. Hey, I'm glad that you guys are really excited about that. All right, so there it is. I don't have to write that out. I can just say, all right, x and x on both sides are gone. So really, this simplifies my problem a great bit right off the bat, because what I have now is 3x and negative 5 minus 1, which would be negative 6. And that equals 3. So look at that. This is the essence of destination plan follow. Our destination, solve for x. So x equals what? That's what the destination was. The plan was, well, analyze first, because you want to simplify easily. Then you want to solve. You want to analyze first, then simplify, then solve. If you simply go in there and try to solve, again, going step by step, it's going to be a bunch of lines, and chances are you might make a mistake if you're writing a bunch on this test. So remember, the whole thing of working smarter, not harder, this is what it's all about here. knowing these concepts well enough to be able to apply some shortcuts. And so the following is just follow this. So we analyzed, boom, we simplified, boom. Now let's go ahead and go through the regular process of solving an equation. Get the x by itself, so I'll add 6 to both sides. Goodbye on the left side, leaving me with 3x equals 9. From there, I'll move to divide 3 on both sides. Cancels on the left, leaving me with x equals 3. And boom, from there, my answer choice here is D. So how do we feel about question number 5? Diana will slay this test. I love it. I love your name there. Feeling good, great, and better. Hey, that's what we're here for, guys. Again, there's so many different types of problems that you'll see, and I'm just trying to help you see it in different ways. So Ashley, so exactly what I'm referring to here. So you're saying, you solved this in a completely different way than you were trying to, and this makes more sense. And I believe that the reason that this may make more sense is because we're not zooming all the way into the first things that we see and then going left and right. No, what we're doing here instead is, hey, let's take a look at the whole picture. And what ideas do I know or that I can recognize? Okay, negatives and positives together cancel out. And if I have the same term on each side, those cancel out as well. So I did that, and then I went down the road. Another method that some of us may use is plug and chug, where we plug in numbers into everything. Now, plugging in can still work, but I would recommend simplifying this first because you don't want to plug in the same number 3, 4, 5 different times. I wouldn't want to do that. So with that said, if you do plug and chug, try to simplify it first into something like the 3x minus 6, and then plug in. So I like that you take your time explaining because my kids are driving me crazy and I'm trying to focus and keep up, and this makes it easy. No worries, Vanessa. I'm glad that I can help out. Again, this is an hour and a half, so it helps all of us out. All right, perfect. Thanks, Kumar. All right, guys, so let's go ahead and look at question number 6. 3, 2, 1, go. Last one of the day. I'm going to give us a full, actually 2 minutes and 30 seconds here. I want to make sure that everybody has a chance to answer this. So 2 minutes, 30 seconds, starting in 3, 2, 1, and go. All right, we're looking at 1 minute left. 1 minute left. You're good, Dania. It's all good. Five, four, three, two, one. Answers. D, B, A, B, D, A, D. Oh, gosh. Oh, gosh. All right, so it happened again. Looks like we're all not on the same page here. But this is a good thing because this is a really good question to ask. This is about pattern recognition. And I'm excited to do this one. I'm excited. So if the pattern above continues, what will the 49th shape be? All right. So no matter what, guys, even if you see a problem that you, again, don't immediately recognize, you get nervous or whatever it is, destination, plan, follow. If it helps you write that out every single time you do a problem, do it. Seriously, do it. So destination, let's start here. Destination. Okay, what am I looking at and what is the question? I'm looking at what looks to be a pattern. So if I'm thinking about it, okay, top left. Wait, let me try to get a yellow here so it actually sticks to the screen. Top left, top right, bottom left. Oh, then top left, top. Ooh, okay, so there might be some pattern here that I'm looking at. I see a pattern here, but let's see if that even is going to help me. So it says, what will the 49th shape be? Oh, if that pattern continues. Okay, yes, we're talking about this. So this is number 1, 2, 3, 4, 5, 6, and it continues. My question is, how many of us, and type yes if you did it, how many of us drew squares all the way through the 49th one? You know, what I'm saying is, did anybody go, okay, I want to see which one the 49th one is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Did anybody do that? Did anybody do that? All right, so we have some people that said yes, some people that said no. Some people said that they used the pattern and multiplied. So I'm going to go ahead and be very honest with you guys. If it's test time, or sorry, if we're practicing, we can feel pretty confident that we can do that, you know, going 1, 2, 3, 4, 5, you know, all the way around. But on test day, I can bet you right now, your anxiety is going to be through the freaking roof. You're going to be like 1, 2, 3, 4, 5, 6, and you're going to get to 25 and you're going to be like, wait, crap, which one was I on? And you're going to start again. And then you might guess, you know, second guess yourself. It's going to be annoying. But if it works for you, it works for you. Let me show you an alternate way that's going to guarantee that you know which one it is without counting yourself. So we want the pattern to continue. We want shape number 49. Okay. So with what we have here, everybody, what's the pattern that we notice? What's the pattern that we notice? In English. In English. What do we notice the pattern is in English? Okay, so it repeats. So Diana, how often does it repeat? What do you mean by that? Let's be more specific there. So that's a good start, but let's be more specific. Squares are moving in an order. Exactly. It's going clockwise, same pattern after 4. There we go, Christina. That's what I was looking for. After every 4, it's the same pattern. When you look at 1, 2, 3, and 4, check it out. What we see are, again, 1, 2, 3, 4. But then after 4, number 5 is the same thing as number 1. Number 2 is the same thing as number 6. So we see that it's going to continue on in that pattern. That's the suggestion that we're seeing right here. So with that said, the pattern that we see is that it repeats after every 4. So again, repeats after every 4. Every 4 boxes. That's the pattern that we see. You're good, Dan. It's all good. So again, the pattern that we see is that it repeats after every 4 boxes. If we're looking for the 49th shape, let's talk about that for a moment. Because if we're looking for the 49th shape, then what this tells me is that, well, if it repeats after every 4, well, how many times does 4 fit inside of 49? So everybody, ask yourself that. How many groups of 4 can fit into 49? Or how many cycles of 4 will we see in 49? Exactly, we'll see 12 complete cycles. So here's what I mean by that. And I'm going to use green and zoom in only on the 4 here. So we see that this is going to be 1, 2, 3, and 4. This will be 5, 6, 7, 8. And we would have then 12, then 16, then 20, then 24. And it would continue on all the way down to 48. Because these are all of the multiples of 4. These are all of the multiples of 4. So with that said, after the 48th one will be the 49th one. But since we're at number 4 here, we're going to start right back here for 49. So that means box number 1, or A, is the answer. So did you guys get that logic and reasoning and how I did that problem? Again, 1, we can just count it all the way around. Or 2, we can use the pattern to get it done in a less stressful manner. So I'm going to go over that again because I want us to really grasp that. So again, what we have here is that it repeats after every 4. So the 4th box will be this. So will the 8th box. So will the 12th, because it's going to repeat again every 4. So just keep adding 4 and keep adding 4. We can get as close to 49 as possible with 48 if we keep adding the 4s. But the thing is, we want the 49th shape, and we know that it's going to repeat after this one the same way that you see here and here. So with that said, boom, that's how we get there. We're all good. The reason that it's not 49 divided by 6, so if it still gave you the same answer, it looks like we may have gotten lucky, or it may have been just a coincidence, because there's no logical way that it would repeat after every 6. Because what this is suggesting is that the 7th one will be a box where this one is covered. And that goes back to number 3, not number 1. So be careful about that. Yeah, we may have gotten lucky and gotten it right this time, but just be careful about applying logic that hasn't been proven moving forward. So Butarasta, the solution here, there's 2 methods again. 1, like I said before, the first way, 1, 2, 3, 4, 5, 6, and just keep going all the way around. And then the better way would be to use the pattern recognition and just simply say, okay, it repeats after every 4. I know that 4 times 12 is 48. And so 1 more is 49. So I'll move 1 shape over, 49, and boom. So those are the 2 different methods that we can use. Both work out just fine. So we have one last problem to do here, everybody. We got one last problem. So who is excited? Who's ready to tackle this one last problem? That's right. Who's ready to kill this? Who's ready? Give me a big old excited yes. Give me as many exclamation points as you want. Less than 100. All right, everybody, let's go ahead and tackle this one. Let's get it. 3, 2, 1, go. I'm giving you 1 minute, 30 seconds. Let's get it done. All right, that is time. 3, 2, 1, answers. And even if you, and let me know if you ran out of time. Let me know if you weren't even able to get to the answer. So a lot of us ran out of time. Some of us are ready, didn't finish. So this is the type of problem that we're gonna wanna work to get right fairly quickly, actually. So here is our solution. And we wanna get quick at these, because again, these are topics that we can recognize on an everyday basis. May take us a little, couple of seconds to know the relationships, but these are concepts that we know. So let's go ahead and start it off here. Destination, plan and follow, as always. So destination, well, we're talking about Bo. So Bo has tape that he's using for a project, and he intends to use some of it. How much of the tape should he have left? Did I read that in English or what, right? I just read that in as English as possible. Bo has this much tape for a project, and he intends to use some of it. How much tape does he have left? That's in English. That's how you want to read it. Avoid the numbers, avoid those measurements. You can go ahead and just gloss over it and talk about what it is generally. That's really what I recommend you do, simply because it's a lot harder to process everything when you're really looking at the important information and the nitty gritty at the same time. Like, no, just start off with the simple stuff, then build your way up. So destination, we want to know how much tape is left. Okay, how much tape is left? So in real life, let's go ahead and just ask ourselves very straightforward, very simply. If we have this much tape and then we use some of it and we want to know how much is left, what simple math idea applies here? Again, if we have this much tape, we use up this much and we want to know how much is left, what simple math do we do if we were actually there? I love it, guys. Yeah, subtraction. That's exactly what we would do. We would kill that right there simply. So we are looking to subtract. Subtract. And, if we're thinking about this in English, the idea is subtract total, right? Subtract what we used from the total. Subtract what you used from the total. That's what you want to do. So that's the idea. Now all we have to do is just plug in those numbers. All right, so what's the total? Well, it looks like Bo has 3.5 yards of tape. So we have 3.5 yards minus All right, and how much did he use? 5 1/3 of a foot. Okay, 5 1/3 feet. And that's what we're subtracting. All right, that's my plan. Now, another thing that I want to take care of before I go into that following phase, before I compute, is recognize that, yards and feet, that's not a good look. Also, well, if I'm trying to think of this, I need these in the same units. But to get these in the same units, we first need to ask ourselves, is there a unit that the problem wants us to do? Is it yards or is it feet? Well, the thing is, the problem actually wants it in inches. So this is why reading the problem in the context is so important. Before we get to calculating, before we do all that hard work, we need to just analyze and see where we need to go. So we need to turn this into inches. All right, we need to turn this into inches. So here's what I'm going to do. I'm going to think of two ways to do this. The first way is to turn yards into feet, then subtract, and then turn the feet into inches. That's one way. Another way is to turn both into inches, then subtract, and then I'm done. So one way is 3 steps, the other way is 2 steps. Which way would you guys like to see? Write it out in the chat box. Would you rather see me go yards to feet, then subtract, and then turn those feet into inches, or turn everything into inches and then subtract? So some say straight to inches, some say yard to feet first, option 1, option 2, the first way. So it looks like, see, this is really cool to see to me, because not everybody likes to do it the same way. See? And there's always more than one way to do it. So I'll do it in both ways to really satisfy both sides there. So let's go ahead and look at number 1, turning them both into feet. What I'm going to do is I will turn the yards into feet, and we know that 1 yard equals 3 feet. So what that tells me is that I need to multiply every yard that I have by 3 to see how many feet are in there. So it's taking 3.5 times 3. Well, what I'm going to have to do here is I'm going to have to actually turn this mixed number into an improper fraction to multiply. So 3.5, what do I do there? Remember, to turn a mixed number into an improper fraction, what you want to do is multiply the whole number and the denominator, because the denominator is the whole. So the whole is 2 pieces. So we have 3 groups of 2 pieces because it's 3 wholes. So 3 times 2 is 6. And then you'll add the result to the numerator. So that 6 plus 1 is 7. 7 over 2 times 3. 3 is the same thing as saying 3 over 1. So I can just write it like that if I'd like to. Again, anything divided by 1 is just itself. So we have 7/2 times 3 over 1, which turns into 21 over 2. So with that said, this would turn into 21 over 2. 21 over 2, we can go ahead and convert that back into a mixed number if we'd like to. That would be 10.5. So we have 10.5 feet minus the 5 1/3 feet that we had from earlier. So from here, now we can just go ahead and subtract, and we're done. So 10 minus 5 is 5. However, though, what's 1/2 minus 1/3? So from here, what we can do is, well, turn them into the fraction with the same denominator. So with that said, I can turn these both into a denominator of 6. Because 2 and 3 both go into 6. So with that said, 1/2 of 6 is 3. 1/3 of 6 is 2. So 3/6 minus 2/6, that would become 1/6. So we have 5 1/6 feet. From there, what we would do, remember we wanted this to end up in inches. So what we have to do here is multiply by 12, because every foot contains 12 inches. We want that knowledge as well. So from there, we multiply that by 12. 5 times 12 is 60. 1 over 6 times 12 is 2. Oops, I didn't write it out there. Giving me 62 inches, making A the answer. So did that process make sense? And if not, let me know, because we're going to get ready to go over the second method now. But that was the first method. Again, turning yards into feet, doing the subtraction, and then doubling back and making it all inches at the end. Who liked that method? Yes or no? So Samantha likes it, and Dira's like, not really. Veronica's like, no, but Ollie, Wendy got it. Clara. So look at that, half and half again. So it looks like those of us that really wanted this method enjoyed it. Those of us that wanted the other method kind of said, nah. The 1/3 into inches. So we're going to do that right now. So we're going to turn both into inches right now. Let's do this in blue. 3.5 yards minus 5 1/3 feet. So let's start off with the yards, and let's turn that straight into inches. So we're going to begin by converting this into a mixed number. Just like last time, it was 7 over 2 yards. From here, to turn it into feet, we'll multiply by 3. So 7/2 times 3 over 1, it gives us that 21 over 2. And this is 21 over 2 feet. Okay. Now, we want to turn this into inches now. And what we're going to do, let me actually use purple, is we're now going to multiply by 12 to make this into inches. So 21 over 2 multiplied by 12 over 1. We don't have to do the complicated multiplication when we have a 2 and a 12. Cancels out to make a 6. So from there, we got 21 times 6, giving us 126 inches. The 5 1/3 feet, all we have to do here, convert that first into a mixed number, giving us 16 over 3. Again, 5 times 3, 15, plus 1 is 16. From there, that's how many feet we have, times 12 to get to inches. So from here, we're going to have 16 over 3 times 12 over 1, giving me 16 times 4 instead. And that's going to end up being 64 inches. So once we subtract these two, we'll end up having 62 inches left over. And remember, this is 62 inches of tape. So I had to kind of speed up that process there at the end. So I do apologize, because I want to make sure I let you guys out of here on time. But those are both methods. Both are equally, I would say, as complicated, because they both involve the same exact conversions. So, it really at that point just depends on preference, because again, all we're doing here is subtracting and then converting yards and feet into inches. The way that you do that, the order that you do that in, really doesn't matter in this problem. So it's really about your preference. So with that said, destination plan follow. What's the final verdict? On a scale of 1 to 10, how useful is destination plan follow? On a scale of 1 to 10, how useful is it? I am curious. You are supposed to be able to do that after a certain point. Yeah. Right. I love that we said 8 now and then 10 when you get it. That's exact. I love it. I love hearing that, because when you're practicing this for the first time, it takes a lot of effort to really, guide yourself in that way and to recognize when you're stuck. But with practice, you'll be able to see, oh, I get the destination part. I know what's going on. I know what I'm trying to look for. I just don't know what math I need to use. Boom, that tells you that you need to learn on how to recognize the math in the context. If you're not able to figure out what the question is itself, then interpreting the problem is another issue for you. So it's really about working through from what you have to what you need to figure out. Practice, practice, practice. Exactly. Exactly. So with that said, everybody, throughout this whole craziness going on in the world, it's really all about making sure that we're still preparing the right way. I know we have a lot of time and a lot of us are at home. So with that said, a lot of us have been to these webinars, and what we've been doing is we've made everything on our websites 50% off, absolutely everything. So, with that said, if you're looking for test prep certification that actually helps, if you're looking for courses and materials and resources that actually work because the teachers there are actually speaking in a way that you can understand it, hey, thelearningliaisons.com is for you. All of our online resources, all of our stuff, 50% off all the way through April 1st using the code STAY AT HOME in all caps. There you go. It's easy to use and you're good. But with that said, what did you guys think of the entire session? Because I know Destination Plan Follow was the theme, but did you guys like the flow of the session? Did you like how many problems we did, how we got through it? Give me that live feedback. I love it. That way we can continue improving for next time. Oh, sweet. Perfect. And thank you guys for your time. Are you serious? Like, you guys are taking an hour out of your day, an hour and a half out of your day to be here. And, I'm just here to help anybody that wants to help themselves. And that's clearly y'all. So I'm proud that I can be part of this. I'm glad that I can help you out. Seriously. Fred, I'll keep that in mind. Thank you. Hey, you guys are welcome. So again, guys, save 50% off. If you are trying to pass and get ready to pass those tests once this craziness is over, this is your chance here. Take 50% off of everything on the website. Get our courses, ask us questions, communicate with us all the way until you pass. We put in all of that work and we have everything on your side to pass. So Diana, we will be posting this. This is actually available in our Facebook groups that you're in, that you found this through. So if you are in Facebook, the video is actually live in there right now that you can go back and search through. Very good. Yeah, Clamar, so with all the questions that I'm involved in terms of the video, I always go through every type of solution as in detail as possible. Because again, remember how earlier I said I hated it when my professors didn't take us from where we were to where they were. They were kind of just speaking from a textbook, hoping they could grab whoever they could. I go the complete opposite way. I want to meet every learner where they are, bring them up to where I believe they need to be successful. That's what I do, and that's how I do it. Oh, Danny, you don't have Facebook? So we're going to email you a link to the recording then. That way you have access to the recording on your email. So what sucks about the math video yesterday, yeah, it was really choppy in the audio. I don't believe that we published it. I can ask Dr. A. Hey, appreciate the love, Kumar. Hey, you're welcome. Hey, Ollie, right now we don't have any sessions planned for the pre-K through 3, but learning about fractions, decompositions, improper, mixed numbers, how to multiply atom, word problems, those are the subjects that you want to, topics that you want to look at for pre-K through 3. Hey, thanks, James. Hey, you're welcome. Anytime. So guys, I'm going to be up here for the next 5 minutes. I'm going to keep this room open for the next 5 minutes. So if you have anything at all that you want to ask or anything that you have questions about while you sign up for anything, just let me know. I'm here to answer any and all questions.
When you pass, not if you pass.